இல்ல இல்ல ஒரு 10 நிமிஷம் நான் அதுக்கப்புறம்.
ஹலோ சார்.
சார் என்ன
சார்
மாலினி யூடியூப்ல நிறைய வர்றாங்களா?
வராங்க மேம் வராங்க.
சரிப்பா.
சார் இருக்காரா தெரியல.
சார் இருக்காங்க.
இருக்காங்களா?
இருக்காங்க. சார் ஸ்டார்ட் பண்ணிடலாமா?
சார்
ஃபுல்லா எழுதி பாக்குறது அந்த வேலையா பார்த்துட்டு இருக்காங்க.
சார்
மாலினி ரெக்கார்ட் பண்ணிருடா.
ஓகே மேம். சார்
சார் அவர் போன் பண்ணி கேளு.
போன் எடுக்க மாட்டேன்.
மாலினி போன் பண்ணுடா. மாலினி
போன் எடுக்கல மேம். அந்த போன் அடிச்சிட்டு இருக்கேன் மேம். சார்
சார் நீ அழகப்பன் சார்னு கூட அப்பதான். போர்ட்ல எழுதி பாக்குறதுமா அப்படிமா இருக்காது.
மேடம் சொல்லுங்க மேடம்.
சார் ஆரம்பிச்சிடலாமா சார்?
மேடம் வணக்கம்
சார். ஸ்டார்ட் பண்ணிடலாமா சார்?
ஸ்டார்ட்.
மேடம் சொல்லுங்க
சார். shall I start this program sir?
ஹலோ
ஹலோ
ஹலோ மேடம்.
சார் ஸ்டார்ட் பண்ணிடலாமான்னு கேக்குறாங்க.
சார்
ப்ரோக்ராம் ஸ்டார்ட் பண்ணிடலாமா சார்?
சார் start the program sir.
கேக்குது மேடம்.
கேக்குதா சார்? கேக்குது சார். start the program sir.
மேம் மேம்
shall I start the program sir? ப்ரோக்ராம் ஸ்டார்ட் பண்ணிடலாமா சார்?
சார் ப்ரோக்ராம் ஸ்டார்ட் பண்ணலாமான்னு கேட்டேன். ஓகே ஓகே சார். தேங்க்யூ சார். உங்களுக்கு தெரியல கேட்குறது. ஓகே மேம். சார் ஓகே சொல்லிட்டாங்க. சாருதர்ஷினி.
எஸ் மேம்.
பேசுறது கேக்குதா?
ஓகே கேக்குது சார். Let us start.
Ma'am.
Okay, ma'am.
கேக்குது சார், audible இருக்கு சார்.
Good morning to all. Thank you to each and every one of you for being here with us in today's webinar. Here, you all assemble for an awesome webinar on applications of fuzzy search and fuzzy logic under the Virudhunagar district cluster of colleges joint faculty program in mathematics. Now, I extend a warm welcome to our Honorable HOD Ma'am, Mrs. D. Rosaline Nyanakumari, and our Honorable Chief Guest, and all the faculty members of various colleges, and to the rocking students of member colleges of mathematics department. I consider it a great honor to welcome Mrs. D. Nyanakumari, Head of Department of Mathematics, to specially welcome all and our Honorable Chief Guest.
Good morning to all. On behalf of the management, principal and the faculty members, I feel privileged to welcome the gathering. On behalf of mathematics, I welcome all the faculties and students. Sir, கேக்குதா சார்?
Sir, I am audible to you, sir. கேக்குது ma'am. I am audible ma'am.
சரி ma'am. Good morning to all. On behalf of management, principal and the faculty of mathematics, I feel privileged to welcome the gathering. I welcome all the faculty and the students from the Members College of Virudhunagar District College Joint Faculty Program for this webinar. It is my great pleasure to welcome and introduce our enthusiastic Chief Guest, Dr. M. Azhagappan, Head Department of Mathematics, Controller of Examination of Yadava College, Madurai. He studied BSc degree in Yadava College and MSc, MPhil and PhD in Madurai Kamaraj University. He had 20 years of teaching experience and published many national and international level research papers. He organized many conference, seminar and workshop and coordinator for government funded program. He acted as a reserve person for more than 40 programs and also create many e-content YouTube videos on all branches of mathematics. He is a member of a board of studies, Yadava College, Karmathur. He plays many leadership roles like assistant controller of கேக்கலையா சார்?
சார்
இப்ப கேக்குதா சார்?
நீங்க பேசுறது கேட்கல
சார். நீங்க பேசுறது ஆடியபிளா தான் சார் இருக்கு. உங்களுக்கு ஆடியபிள் இல்லையா சார்?
He is a member of the board of studies of Yadava College of Karmathur. He plays many leadership roles like assistant controller of examination, program officer and Red Cross Society and Red Ribbon Club, lifetime members of Indian Mathematical Society, members in International Grant Fund Water Conference, coordinate the intensive training of part of extension activities. As a coordinator of ECO and WASH, he has taken prize steps and powerful contribution.
நீங்க மியூட் எடுத்து பேசுங்க. மியூட் எடுங்க.
சார் HOD மேம் பேசிட்டு
கேட்கல.
And powerful contribution to the society by the organizing various awareness program about water, sanitation and hygiene. Once again, I welcome our chief guest to enthusiastic and the application of fuzzy sets and fuzzy logic. Hope we will have a fruitful section today. Once again, I welcome you all. Malini?
Okay, ma'am. Thank you, ma'am.
Okay, thank you, pa.
Sir? Sir?
நான் பேசுனது கேட்டுச்சாப்பா மாலினி?
கேட்டுச்சு மேம்.
சார வர சொல்லுப்பா.
இருக்காங்க மேம் லைன்ல தான்.
ஸ்டார்ட் பண்ண சொல்லு சார.
ஓகே மேம். அதான் அவங்களுக்கு கேட்கல போல மேம்.
மேம் போர்டு விசிபிளா இருக்கா மாலினி மேம்?
இருக்கு சார்.
மாலினி மேம்?
எஸ் சார், விசிபிள் சார். சார் இட் இஸ் விசிபிள்.
மாலினி மேம்?
சார் இட் இஸ் விசிபிள் சார்.
சாருக்கு நம்ம பேசுறது கேட்கலன்னு நினைக்கிறேன். சார் ஸ்டார்ட் பண்ணுங்க சார்.
சார் நீங்க இப்ப நாங்க பேசுறது உங்களுக்கு ரீச் ஆகல போல, ஆனா விசிபிளா தான் சார் இருக்கு.
மாலினி என்னாச்சு? மாலினி
இருக்காங்க சார். ஹலோ
பாருங்க.
ஹலோ சொல்லுங்க சார். வெல்கம் பண்ணிட்டாங்க சார்.
Good morning.
Good morning, sir.
Please, anyone respond? Good morning.
Good morning, sir.
Morning, sir.
Good morning to all.
Good morning, sir.
Good morning everybody. I will go.
Hello.
Okay, shall I start?
Okay, sir.
Okay, good.
Okay, sir. We'll start the programs.
Good morning all. First of all, I thank the management of SFR College, principal of SFR, head of the Department of Mathematics, faculty members of Department of Mathematics, especially Professor Malini for inviting me to this webinar. Thank you, one and all. Today's topic is fuzzy sets and fuzzy logic. Fuzzy sets and fuzzy logic and its applications. First of all, what is set? First of all, what is classical set? Fuzzy set. I am going to give three concepts. Number one is how that set becomes a fuzzy set. Then what is the relation between fuzzy and classical? This is the first part. Then second one is how we do research using this fuzzy set. Second part. Third part is application. Now, the set, that set is called classical set or crisp set. Or crisp set. Let us consider a set X. Let us consider a set X consisting of first semester classes X1, X2. There are 20 students in a class first semester. There are 20 students in a first semester. I am taking one subset. A is a subset of X. That A represents, I said A represents the students who have got distinction in algebra. Distinction in algebra. Distinction in the algebra means the students who have got more than 80 marks in algebra. Suppose let us take X3 and X9 and X18. There are 3 students got more than 80 marks in algebra. So this is the subset. This is the set. This is the subset. Okay. The same scenario, I am going to define one function. That function is called characteristics function. That function is called characteristics function. It's defined on X into the set consisting of 0 and 1. The set consisting of 0 and 1. So defined by, so this characteristic psi of X is equal to 1 if X belongs to A. If this is equal to 0, if X does not belong to E. X does not belong to E. Okay. So, X is a subset which represents some concept. If that particular element satisfies this concept, then automatically that element will come to the subset. Okay, so therefore this function, this characteristics function is equivalent to the representing subset A. Equivalent to the representing subset A. Okay, so psi A of S is a function which is equivalent to a subset. So therefore, in classical also, a set is also a function. Classical also. Here, suppose if we taking 81, X80 mark maybe 99. Okay, but there is no difference by seeing this subset A. X3 and X18, generally we can say that the two students have 4%. That's all. But there is no difference. But X18 is but we want
sir, excuse me, sir. కొంచెం audible అల్ల కొల్ల కొంచెం మైక్ sir.
Each element has a membership value. Each element has a membership value either 0 or 1. So this is nothing but classical set or crisp set or traditional set. Why we say that it is crisp? Either 0 or 1. But if you ask one question, you have to say either yes or no. Then we can say that this is crisp. This is called a crisp set. So far from the small classes onwards, what we have studied, that all the sets are crisp sets. Okay. Now, that how that first is set comes. The same x I will take x1, x2, etc. x10. The same x I am going to take. Okay. Then again I am going to define one subset. A represents the students who are tall. In classical, we got distinction in algebra. Here, A represents the students who are tall. How we define them? Who are tall means what? So here, this tall is called linguistic variable. Linguistic variable. What does it mean for linguistic variable? A variable whose values are not numbers. This is the variable whose values are not numbers. Either a word or a sentence like that. This is called linguistic variable. So in this case tall means what? It depends from place to place. In Japan, tall means certain height will be there. In America, that's different. So this differs from place to place. Suppose in your class, X9 is tall. We feel that we can give 1. X1 is not tall. Short, that is 0. In between, we should give a membership values. we should give a membership value. That is nothing but first. So first is that is again a function, characteristic function defined on x, into instead of the set 0, 1, I am going to take the closed interval 0, 1. The closed interval 0, 1. That means here that magnitude of the membership value is given to all the members. Not only that, before that what we discussed is 81 is also goes to 1, 99 is also goes to 1, but here we can show the difference. So here, suppose mu a sometimes denoted by simply I can write a is nothing but mu a. The representation of persistent is nothing but here is x1. Suppose the membership value of x1 is 0. Suppose x2, suppose we feel that 170 centimeter is tall, I can give 1. Suppose 168 is there, I cannot give 1, so therefore I can give, suppose x3 0.9, x3 0.9. Suppose 156 or 170, I can give 0.4, something like that. So therefore, so suppose that person x4 is tall, I can give membership value 1. Suppose x4 is short, I cannot say that he is tall. So therefore I can give membership value 0. In between, we can give the membership values in between 0 and 1. In between 0 and 1. So therefore, this kind of things is called some 0.8 or something like that. This kind of set is called fuzzy set. This kind of set is called fuzzy set. Suppose simply I am asking, are you a student? If I ask like that, you can say that yes. So we can give the membership value 1. Suppose you are going for a part-time job. 4 hours you are working outside, 6 hours you are studying. If I ask the same question, you cannot say that yes, I am a student, because you are also working. You cannot immediately say that I am a student. So therefore, in this case, that confusion will come whether I have to say yes or no. For this particular question, if you are not able to say yes or no, so in this case, fussiness in the sense, literally speaking, confusion. Fussiness arises, so we can give the membership value 0 to 1 in between all the values. Numerous values, uncountable values are there in between. So this set is called fuzzy set. So therefore, fuzzy set is a function. Again, fuzzy set is a function from x into the closed interval 0, 1. The closed interval 0, 1. X is a classical set. X is a classical set. This is a function. Simply, I can write simply a. So this is actually psi of a. Simply, I can write a. So therefore, this is the fuzzy set. Okay. Here, operations of fuzzy sets. Operations. A is a subset of B. A union B. A and B, B2 fuzzy sets depend on X. A intersection B, the complement of a set. We know that in a classical set, A is a subset of B means every element of A is also an element of B. A union B is nothing but the set of all elements is that X belongs to A or X belongs to B. A intersection B is equal to the set of all X such that X belongs to A and X belongs to B. So easily we can say that A intersection B is a subset of A union B. This is classical already. This is very trivial result. So A complement is equal to the set of all X that X not A. Because X is a classical set. Because X is a classical set. So these properties are very familiar. Okay. Now, how that we define persistent? How we define persistent? A is a subset of B in the sense A of X is less than or equal to B of X for all X in X. The A of X is called membership value. Actually, what I defined is A is equal to, here is X1, here is 0.8, so this is nothing but A of X1. X1 is a member, A of X1 is the membership value of X1. Okay. So therefore, this is A of X1 is a value, numbers. The A of X1 always lies between 0 and 1, lies between 0 and 1. So therefore, X1. So similarly, A union B in the sense, A union B is equal to the set of all X in X. Therefore, what I am going to say that A union B of X is equal to A union B of X is equal to maximum of A union B of X is equal to maximum of A of X comma B of X. A of X comma B of X. A intersection B of X is equal to minimum of A of X comma B of X. A complement of X is equal to 1 minus A of X. 1 minus A of X. Okay. Some properties will be satisfied in classical set. Some properties will not satisfy in persistent set. That is most important. Where this persistent and the classical sets differ, suppose let us take, so I am going to give an example. Suppose let us take X is equal to X1, X2, X3. I am going to take one persistent defined on X. I can take as many number of persistents from X. So that A is equal to A is one of the persistent. So the membership value is 0.2 plus 1 by X2 plus X3 is equal to 0.8. Okay. I can define another persistent. So this is 0.3 X1 plus this is 0 by X2 plus 0.4 by X3. A union B is nothing but A union B is equal to X1 whose membership value is here is a set of all A union B of X. A union B of X. A union B of X1 will come here. So A union B of x1 plus A union B of x2 divided by x2 plus A union B of x3 divided by x3. So this is equal to A union B of x2 is equal to maximum of A of x1 comma B of x1. So therefore 0.2, 0.3, which one is maximum? Therefore 0.3 divided by x1. Similarly, plus 1 by x2, 1 and 0, maximum is 0.8, 0.4, the maximum is 0.8 divided by x3. This is not a division, this is not addition, all symbols, that's all. This is the structure of resistor. Okay. So, or otherwise I can write x comma, x1 comma 0.3, x1 comma 0.3 and x2 comma x2 comma 1, x3 comma 0.8 also we can write. Okay. So therefore, this is A union B. Similarly, I can write A intersection B. A intersection B is nothing but minimum. Minimum is what? Here is 0.2 divided by x1. Next minimum is 0 divided by x2. Then next minimum is 0.4 divided by x3. Divided by x3. Okay. So therefore, intersection A complement. A complement is equal to, so this is nothing but x1. Here is 1 minus A of x1, 0.8. Here this is x2. 1 minus 1, that is 0. Then x3, 0.2. The one important thing is, in classical set theory, universal set is x. Empty set is denoted by empty. Okay. Here, in Fuzzy set theory, classical set is denoted by, in Fuzzy set theory, universal set is denoted by 1 and empty set is denoted by 0. That means all the membership value of each element or the membership value of each element is 1. All the values are 1, 1, 1, 1 or something. Here all the values are 0. So here A we have A union, and already we know that in classical set A union A complement is equal to opponent. A intersection A complement is equal to empty set. But this is true in classical set. These properties are true in classical set, but these are not true in fuzzy set. These two properties are not true in fuzzy set. In fuzzy set. How? This is A. What about A? A is equal to 0.2 by x1, 1 by x2, 0.8 by x3. What about A union A complement? Again, it's the maximum. So 0.8 plus by x1 plus 1 by x2 plus 0.8 by x3. So this is not equal to 1. 1 means what? 1 by x1 plus 1 by x2 plus 1 by x3. So this is nothing but 1. This is nothing but universal set. Okay. So therefore all that means what? X1 belongs to the set, x2 belongs to the set, automatically the x becomes what? X. Automatically. So therefore, so here this is not equal to what? Similarly, A intersection A complement is equal to, so intersection A complement is equal to 0.2 by x1 plus 0 by x2 plus 0.2 by x3. Again, this is not equal to empty set. So therefore, this is the difference between the fuzzy set and classical set. So some operations will be satisfied in classical set, some operations will not satisfy in fuzzy set. That is most important. Now, I can say that any classical set is fuzzy set. Classical set is a set, crisp set. Crisp, classical, traditional. These three things are said. For any crisp set is fuzzy set, but fuzzy set need not be crisp set. Crisp set. I can say that in the previous example, A is equal to x3, x9, x18. This also I can write in fuzzy form. What about fuzzy form? So this is equal to x1, 0 by x1 plus 0 by x2 plus 1 by x3 plus 1 by x3 plus 0 by x4 plus etc. plus 1 by x9 plus etc. 0 by x9. So therefore again 1 by x18 plus 0 by x19 plus 0 by x20. So therefore, so this set and this set, both sets are same representation. So this is classical set. This set I can write like that. I can write like that. So therefore, any classical set, any crisp set, I can write in fuzzy form. I can write in fuzzy form. So therefore, I can say that any crisp set is a fuzzy set. But suppose I have given a one fuzzy set. This is equal to 0.2 by 8 by x1 plus 0.3 by x2 plus 1 by x3. This set I cannot write in classical form. Crisp form. Okay. So this is most important. Okay. Then there are many operations are there. Alpha cuts are there. Simply I can say alpha cuts. A is the first set. A alpha, I can say that alpha cut of A. This is nothing but the set of all x in x such that A of x is greater than or equal to alpha. A of x is greater than or equal to alpha. So this is also a subset of x only. This is not a first set. That is most important. So this is the crisp set. This is the crisp set. Okay. So A alpha is not a fuzzy set, whereas A is a fuzzy set. A is a fuzzy set. This is important concept. So why we use this A alpha means in traditional set we know that we have convex set. We know that X is a crisp set. A is a subset of X. A is said to be convex. A is said to be convex. So we have certain formula. If lambda x plus 1 minus lambda y belongs to A for all x and y in X, and lambda belongs to the closed interval 0, 1. This is the definition of convex set. A subset A is said to be a convex if this condition is satisfied. It means what? Let us take any set. If you take any two elements, if you join them, if you take a line joining them, again this line also belongs to the same set. That set is called the convex set. The set is called the convex. This is convex. This is not convex. So here I can take one point, here I can take another point. If you take the line between 2 points, definitely that line does not belong to this set. Therefore, this is not convex, this is convex. So these are all happening in classical crisp set. You come to fuzzy set. A set, and we are going to discuss about a subset is said to be convex. Instead of, we are going to say that A alpha is convex. But because A alpha means what? A alpha is a classical set, crisp set. So that we know that what is the definition of convex. So therefore, that plays a very important role. So each and every concept we are making, trying to convert into fuzzy sets. Okay. When we prove, when we say that a fuzzy set is convex, instead of proving alpha cut of A is convex. So therefore, a fuzzy set A is said to be convex if and only if alpha cut of A is convex. Alpha cut of A is convex. So therefore, for these cases, so we need alpha cut. There are many properties are there in alpha cut. Okay. Next. We know that function we know. Okay. We know that F is a classical set and Y is also a crisp set. F is a function. We know that. We are very familiar with this. F is said to be a function if each element of X there exists a unique element of Y such that F of X is equal to Y. That we know that we are strong in that. When we say that this F is falsified. This F is falsified if this F is falsified if that F is extended to this F is extended to the subsets of fuzzy subsets of X into fuzzy subsets of Y. And because classical set we know, operations we know, fuzzy set, operations we know, certain operations will be satisfied, certain operations will not satisfy in fuzzy set. So similarly, F is a function, we know that. Okay. When we say that this function is falsified function, so therefore the function is extended to the fuzzy subsets of X into fuzzy subsets of Y. Let us take the same F. I can denote this is nothing but F of X into F of Y. F of X is nothing but a collection of all fuzzy sets of X. F of Y is nothing but a collection of all fuzzy sets of Y. Two sets we have. Here is X, here is Y. Here is X, here is Y. Okay. Here, how will you define? So, here is fuzzy set, collection of all fuzzy subsets. Here is also a collection of fuzzy subsets of X. Okay. Here, F of X is equal to, defined by F of X is equal to maximum of A of X, A I of X. maximum of a of x divided by, that is f of x is equal to maximum of a of x. Maximum of a of x. Simply I can say that, very simple, this is x, this is y. How that function is specified? A, B, C, D. This is x. This is y. This is as usual function. So here is M, N, O. Okay. So this is the function. This is the function. So it's the M and O. Okay. Here we know that this is the function. By our definition, each element of the domain has a unique image. Each element has a unique image. Therefore, this is the function. Now, I can extend this function into a subset f of x. F from f of x into f of x. This is most important concept. Suppose I can take one element from here, A. A is equal to, so here is A, 0.2, B, 0.3, 0, C, 0.8, D, plus 1, E. Persist. Okay. Now, I can have another persistent D. The members of the answer persistent I can have B. This is M. So A is a persistent dependent on X. I can construct another persistent. How I can construct? So you see how many three images are there. So you have to calculate maximum of A of A, comma A of B. So this is nothing but what? Maximum of A of A, comma A of B is equal to. Here is nothing but 0.3. Similarly, yeah, maximum of C only. Maximum of C is equal to 0. Plus 4. Maximum of D and E is 1. What about P? There is no pre-image. So therefore, the membership value is 0. Therefore, the membership value is 0. So therefore, B of M is nothing but F of A image. I can say that F of A. I can F of A is equal to B. F of A is equal to this. So therefore, F of A is nothing but maximum of A, comma A of D divided by Mn. You have to find how many free images are there. You have to take the maximum value of that membership. So this is the specified function. What are the properties are available in fuzzy classical function, fuzzy functions, whether it is true or not? F of A union B is equal to F of A plus F of B or something like that, or F of A union F of B, whether it is true or not, we can compare. We can compare. So how that inverse function? How that inverse function? F inverse is nothing but F of Y into F of X. This is nothing but F inverse of B of F inverse of actually the inverse is taken like B of F inverse of B of F inverse of B of X is equal F of X is equal to this is equal to B of F of X. F inverse of B of x is equal to D of f of x. Okay. So this is nothing but F inverse of B of x is equal to F P of f of x, inverse function. So therefore, we have a lot of properties, lot of results in functions. Then immediately we can check that whether it is true in fuzzy set or whether it is not true in fuzzy set. What is happening? We can find, we can analyze immediately. Okay, then another concept is first the number. Another concept is first the number. Okay. First the number. Suppose let us take a fuzzy set. Fuzzy set is a function a from x into the closed interval 0, 1. Closed interval 0, 1. Instead of taking this x, let us take real number. Let us take real number into closed interval 0, 1. Fuzzy set automatically becomes fuzzy number. This plays a very important role in applications. Then we'll tell you later. So therefore, fuzzy set, fuzzy number. There are many operations are there. So therefore, I'm not going into very detail because of time. The next thing is, so far you can have an idea about classical set as well as fuzzy set. About the structure, the structure we know, fuzzy set structure we know, classical set structure we know, operations we know, here is operations we know. So these things are, we have to, actually these things are, we have seen that. Now, how to do research using fuzzy set? We know that topology. Firstly, okay. For topology in the sense what? Let X be a non-empty set. Tau be a collection of subsets of X. Tau be a collection of subsets of X. This tau is called topology. If three conditions are satisfied, tau is called topology. If X and empty belongs to tau. Number two, arbitrary union of open sets again belongs to tau for all AI belongs to tau. Okay. Number three, finite intersection of open set is also belongs to tau for all AI to tau. So therefore, this is topology. Tau is topology. You have to check the three conditions. And X comma tau is called topological space. These are all very familiar. And also we know that if X consists of only one element, how many topologies possible? Only one element. How many topologies possible? only one number of topologies. Only one topology possible. N is equal to 2. There are 4 topologies possible. And the number of topologies. Number of topologies possible. N is equal to 3. There are 29 topologies are possible. N is equal to 4. 55 topologies are possible. 5, 6, 9, 4, 2 topologies are possible. It goes like that. I am asking one question. Is there any method? Is there any method to know the number of topologies? To know the number of topologies in a set, in a finite set, This is the question. Is there any method? Is there any method to know the number of topologies is a set? The answer is no. The answer is no. This is a very important open problem nowadays. If you are able to solve this problem, you will be earning, you will be getting $1 million rupees. $1 million rupees you can get. $1 million you can get it. $1 million you can get it. So these are the open problem. So topology, that's a very interesting area. How we connect with the fuzzy. How we connect with fuzzy. Okay. Fuzzy set also we know that. This area. Here in tau, the elements are called open sets. Here is also X. Tau be a collection of fuzzy sets of X. Tau be a collection of fuzzy subsets of X. Fuzzy subsets of X. Okay. Here, the same thing. This tau is called a fuzzy topology. This tau is called a fuzzy topology. If the same 3 conditions, instead of X, I am going to write 1, instead of MD, 0 belongs to tau. Now because 1 is also a fuzzy set, 0 is also a fuzzy set, definitely the 2 sets belong to tau. Number 2 is arbitrary union of subsets belongs to tau. Here the same thing, arbitrary union of fuzzy sets also belong to tau. So what about arbitrary union? This is nothing but supremum of union of A is equal to supremum of AI of X. Similarly, finite intersection also belongs to tau. Now, this X comma tau is called fuzzy topological space. This X comma tau is called fuzzy topological space. Okay, fuzzy set we know that this is different, topology is different, so therefore we connect this and that, so we will be getting a fuzzy topological space. Whatever the results available in topology, again we are going to analyze the results, whether it is true or it is false in fuzzy topological space. That is nothing but result. Not only like that, this is a small example I am giving you. Then suppose persistent we have, you can take another concept, topology, leave it. Graph theory, you come to graph theory. Graph theory, we know that, definition we know that. Graph G comma, G is a graph. P comma E, ordered pair. Vertices we know that. Edges we know that. That how we connect everything we know. So simply how to connect with the fuzzy. So this is nothing but a fuzzy graph. Will be getting fuzzy graph. Will be getting fuzzy graph. So similarly, the research is very easy now. But you have to concentrate, you have to analyze. You should learn the basic concepts very well. That is most important. Basic definitions, basic concepts. If you learn it, definitely you can do the research simply. Okay. So likewise, so this is a smaller idea I can give you. Enthusiastic persistent is there. Bipolar valued persistent is there. Bipolar valued in the sense, the membership grade already we have taken 0 to 1. Here I am going to take -1 to 1. -1 to 1. Bipolar valued. This can be written as -1 to 0 and 0 to 1. There are many concepts are there. So bipolar valued fuzzy topological space. So these are the things. Next one is, the next concept is application. The next concept is application. First of all, very simple application. First logic I am going to use it. I am going to say that usually, suppose in our home we use fan. Okay. Suppose there is no regulator, we can either switch on or switch off. If we switch on, that is nothing but 1. If we switch off, that is 0 or off. On means 1, off means it's not. And control three again. If if temperature is record, switch off the fan. That is 0. If temperature is record, turn down the fan. If temperature is hot, speed up the fan. So if property, if variable, okay, is property, then action. Mostly, first logic use the same concept. If the temperature is high, then switch on or speed up or something like that. So these are under control. These are under control. So therefore, this is called the fuzzy control. After this is some washing machine you can see that fuzzy logic inbuilt with this washing machine. Like that they will give. Nowadays, fan. This is the fan. That the fuzzy logic how they are using it, you can see that. After some times, here, suppose let us say here there are 4 variables. There are 4 variables. Then here 0.25, 0.5, 0.75, 1 or something like that is there. So later on, some regulator has come without any, whatever the speed you want, you can adjust. Whatever the speed you want, you can adjust. In between 1 and 2 also you can adjust. So this is a discrete fuzzy, this is continuous fuzzy. So therefore, fuzzy logic is used in likewise. So this is the very basic concept. Likewise, washing machine. Washing machine is there. Okay. So some control will be done in washing machine. Some sensors will identify how the dirt is there. Accordingly, that machine, that logic, add the water, rinse timing, wash timing, everything that fuzzy control, fuzzy logic provides. Fuzzy logic provides. So accordingly, that lifespan of the machine also will be good. So therefore, washing machine, there I can say that many things I can say that about fuzzy logic washing machine. Temperature of the water also it can identify. The quantity of the dirt is also identified. Accordingly, that machine will adjust all the things. Then ultimately, the wash, that outcome, the productivity is also good. Then similarly, refrigerator. Refrigerator is also one of the main application of fuzzy. Same thing, all wherever home appliances that use the concept is if then statement only. If then statement only. If this situation occurs, you do this. If this situation occurs, you do this. So this is the fuzzy control system. Not only that, civil engineering, medical, robotic, fuzzy graphics are also used in signal control system. Signal control system also used. So therefore, nowadays fuzzy set, fuzzy logic is used in almost all. Almost okay. So therefore, I can explain many. I can say that many things because of time. I think I can conclude this session. Ma'am. Ma'am.
Sir. Sir. Sir, I got.
Only ma'am.
Hello, sir.
Students.
Sir, I am audible to you, sir.
Unmute it, your mobile. If you have any doubt, please ask me.
Dear participants, you have any queries, any
Students.
questions? Please put you in chat box.
Students.
Dear participants, you have any questions?
No, ma'am.
These questions. Students, please. You can ask questions.
Dear participants, you have any other questions?
Only, ma'am.
Sir? Sir, I'm audible to you? Sir?
Only, ma'am.
Sir, I'm audible or not, sir? Ma'am? Chadadashni?
Ma'am. No queries are there. I think so. I would like to express our sincere thanks to our honorable chief guest for giving an excellent coverage about the applications of fuzzy sets and fuzzy logic. Now, I am glad to invite Dr. R, Assistant Professor to address a vote of thanks.
Very good afternoon. One and all present here. It's my great privilege to propose vote of thanks on this occasion. First of all, I would like to thank God Almighty for making today's webinar a great success. On behalf of Department of Mathematics, SFR College, I would like to convey my sincere thanks to our management members for granting us permission to organize this webinar under VNR District Cluster College Joint Faculty Program. A special thanks to beloved principal and faculty Palniswari for providing her encouragement and support to make the webinar successful. I extend my gratitude to our HOD Madam, Mrs. D. Roslyn Murray for her guidance and moral support. Next, I would like to thank our chief guest, Dr. M. Azhagappan, Head Department of Mathematics, Controller of Examinations, Yadava College, Madurai, who honor this webinar with excellent, inspirational and interesting speech on the topic application of fuzzy sets and fuzzy logic. I thank Mrs. Vasanti, Assistant Professor of Science, for her technical support. I am happy to express my thanks to all staff, students of Member College in the VNR District Cluster of Colleges. Thank you. One and a half. Thank you, sir.
மேம் இப்போ கேக்குதா நான் பேசுறது?
Okay, sir. Yes, sir.
Okay. இப்போ ஸ்டூடெண்ட்ஸ் லைன்ல இருந்தாங்கன்னா if they have any doubt they can ask. Students, okay மேம் இப்போ அப்ப போர்டு கிளியரா இருந்ததா? எனக்கு இன்னும் நான் பேசுறது நீங்க பேசுறது எனக்கு கேட்க முடியல மேம். ஹலோ
சார் போர்டு
நல்லா இருந்ததா?
கிளியரா தெரியல சார் நீங்க
அப்படி போர்டு விசிபிளா எழுதுறது ஹேண்ட் ரைட்டிங்ல விசிபிளா இல்லையா?